Hello, welcome to day 21 of NTI for math videos. Today's lesson is working on geometry. We've been through most of this in class, actually all of this in class, and some of it you covered in great detail in third grade as well. So this should be a great review lesson and a chance to recharge your minds into geometry. So I'm going to work some with you. I'm going to leave some of them for you to do on your own. So let's look at this first one. And if you remember the difference between line segments, rays, and lines. So think about when we did the movements with our hands and with our arms. And it's asking you which of these is a line segment. Well, I know that a line goes on in both directions forever, so if I was going to do that with my arms, I would hold both of my arms out and keep my fingers pointed out. I know a ray goes on and keeps going in one direction, but has an end point on another end. So I would have, if I was going to show that with my hands, I would do one arm out straight flat with my fist closed, and the other one straight out the other direction with pointed fingers. Well, a line segment is going to have two endpoints. So the way you would do that with your arms is you put both of your arms out straight and put fist at the end of each hand. So which one of these represents endpoints, fist at the ends? A. So A is a representation of a line segment. Remember the difference between, for number 2, is difference between parallel. These two pins are parallel. Perpendicular. They cross with 90-degree angles. And intersecting would be they cross at any way, but there's not a 90-degree angle where they intersect. It could be like this, this, this. And a perpendicular is an intersecting line. It's just a specific type of intersecting lines. So looking at there, which one of these three is parallel? I would like you to mark it yourself. Number 3. Which polygon has two sets of parallel lines? Well, let's look at the lines here. I know this line and this line don't touch, and even if I drew them out, they would not touch. So I'd say these two are parallel. Let's look at these sides. These sides would not cross even if you extended the lines out. So these sides are parallel to each other. Let's look at B. That one has two sets. Let's make sure it's the right answer. This one and this one do not look like they would ever cross even if I extended my lines out. So I'd say this line is parallel to this line. If I extended this one out, it's going to go this way, which is headed dangerously close to the other one that if I extended it out, it's going to cross. So I'd say those sides are not parallel, because if they extended out, they would intersect at some point. Let's try this one. If I extended this one out, it's going to head slightly towards the left, and this one's going to go slightly towards the right. So yes, they would touch at some point. So let's try these lines. If these went out this way, it's slightly leaning to the right. And if this one went out, it slightly leans to the left. So at some point, those lines would intersect. So I'd have to say none of the sides in this shape are parallel. So what is our answer for number 3? Which polygon below has two sets of parallel lines? A. We demonstrated it by extending the lines out if we needed to. Number 4. Let's talk about the difference between an acute angle, obtuse angle, and a right angle. An acute angle is going to be smaller than 90 degrees. So what's 90 degrees? 90-degree angle is those that go straight up, straight out. Excuse my inability to draw a straight line. I don't have my ruler here with me. It's one thing I left at school I need to go back and get. So you're going to bear with me here. But a 90-degree angle is demonstrated by showing the perfect square that could be made in there. So that is a 90-degree angle. You can use the edge of a paper as your representation of this is a 90-degree because this is a perfect square there. So an acute, so this one is a right. Let's draw an acute. An acute is going to be any angle that is less than this 90 degrees. So we'll go ahead and draw our straight line out. And you can do any angle size that is smaller. You remember how to do that with your arms? Right angle is one arm straight up next to your ear and one arm straight out, shoulder straight out to the side. So this is acute. It's tiny. It's acute angle. And so if I know this is a right, this is an acute, what do you think an obtuse is going to look like? Can't be less than 90 because we've already done less than 90 here. It have to be greater than 90. So number 5 has you actually draw an obtuse angle. I'm going to do that right now and help you and show you how to draw an obtuse angle. Take any straight edge. You can take a piece of paper folded up. You can take a notebook, if you have a ruler, whatever you need. The edge to your agenda. And just draw your line, the bottom line. Make sure you put the arrow on the end because this has an end point and an arrow. It's a ray when we're drawing an angle. Then you're going to take your paper and you're going to draw an angle. You're going to make the angle larger than 90 degrees because an obtuse angle is any angle larger than 90 degrees. Is it fair to say that that's larger than 90 degrees? Well, let's test it with my paper theory. If I put my paper in there, if it was 90 degrees, it would come straight up right next to this edge here when I put it in the corner. So this is an obtuse angle. Anything that is greater than 90 degrees or the corner of a piece of regular paper. So going back to number 4, how many acute angles are in this polygon? Well, let's look at this one, and the way I could test it, like I said, we can use a piece of paper. Let's test. Is that less than 90? Nope. Let's test the next angle. Is that less than 90? Nope. I'm going to put it in the corner of each. Nope. Nope. It's hard to fit everything on this table. No. So I just tested all of them. Were any of them less than 90 degrees? No. They were all greater than 90 degrees, which tells me they're all what? Obtuse. So the answer to how many acute is 0, D. There are not any acute angles in this polygon. Shift up to number 6 up here in the middle. Which shape has an obtuse angle? I'm going to let you do that one yourself because I just gave you the tools to be able to test using a piece of paper, the corner of a piece of paper, to test it. Remember, obtuse is greater than 90 degrees. Number 7. Which of these polygons has only right angles? Well, let's look at these polygons. That's one thing that we have not reviewed this year very much because this is something you covered in 3rd grade. So I've created a little image and definition for each. So we're looking at trapezoid, rhombus, and square first. So a trapezoid has 4 sides one set of parallel sides. That was, remember the one we did earlier? Those two would be considered parallel. A rhombus is where the opposite angles are equal and it has 4 sides. The 4 sides don't have to be the same size. The opposite angles have to be equal. A square has 4 right angles, 4 equal sides, and 2 sets of parallel lines. It also can be classified as a rhombus. So rhombus does not have to be equal sides, but one with equal sides would still be considered a rhombus. So all squares are rhombus, but not all rhombus are square. So let's go back to our question. Our question said, which of these polygons has only right angles? Well, you can tell by looking at the picture. Remember the right angles. A right angle is going to have 90 degrees. It's going to be a perfect corner, like you say. So, does trapezoid have any of those perfect corners? No. Does this rhombus have perfect corners? They're slightly here. This one's slightly obtuse. This one's slightly acute. It's kind of hard to tell. I know you're in a video and you can't see it as well, but a rhombus might even look like more of a diamond shape. Like that. And then here's the square. And yes, these are